Recording has started.
Okay, I'm Dr. Mark Miney, and I'm here to speak to you today about the Bionic Leaf Development Kit project, which is a collaborative effort between the Biospherics Working Group and SoundBio Labs, funded by an Amazon Catalyst grant. Most of you are familiar with the old television program, The $6 Million Man, but let's review what we mean by bionic just for a moment here. Bionic means having normal biological capability or performance enhanced by or as if by electronic or electromechanical devices. The most well-known bionic leaf, the so-called Nocera silver bionic leaf, is pictured in this slide. It removes CO2 from air and converts it into fuel, in this case isopropanol. It uses a combined electronic systems with genetically modified microbes. It's 10 times more efficient than biological photosynthesis in removing CO2 from the air and converting it into a fixed chemical product like isopropanol, as opposed to glucose. It does not require arable land, can use water of any quality, and it is powered by the sun. There are many bionic leaf technologies under development now. This is just but one example, and they range from 10 times to 1,000 times more efficient than natural biological photosynthesis, which has a natural upper limit that would preclude it being a good competitor with these bionic devices as a means of removing CO2 from the atmosphere in large quantities efficiently and making it into products such as fuel and food and closing the carbon cycle with regard to human industrial activity. Devices such as the bionic leaf can be used to reduce greenhouse gas emissions, actually remove greenhouse gases from the atmosphere, and convert them to usable products such as fuel, plastics, and food, and do so in a scalable way. Scalable bionic systems have been used for over 100 years to modify Earth's biosphere. The Haber process is an example of one, and it removes molecular nitrogen directly from Earth's atmosphere and converts it to fertilizer, increasing food production beyond the natural carrying capacity of the planet. And this mimics the natural process of molecular nitrogen fixation by bacteria. The internal combustion engine converts fixed carbon into CO2 and is responsible for a large part of the increase in CO2 driving global climate change. It mimics biological respiration. So the Earth already has a bionic biosphere, just one that is increasingly inconsistent with the continued existence of human life on the surface of the planet. Bionic leaf technologies and other such devices have the potential to correct this situation in a scalable and economically desirable way with important political, socioeconomic consequences. Now, as part of all of this, in addition to the work I'll talk to you about in a moment, building the Bionic Leaf Development Kit, I'd like to also mention Project Drawdown. Project Drawdown was developed by Paul Hawkins, the eco-entrepreneur, and he gathered together a group of highly credentialed scientists, engineers, and sociologists and asked the question, what can we do now, or what kinds of technologies and approaches are available in the near future to not just limit carbon dioxide emissions, but actually act to reduce or draw down the amount of CO2 in Earth's atmosphere and thus alleviate the crisis that's been caused by putting all of this carbon dioxide up into Earth's atmosphere. And that's led to his forming an organization called drawdown.org. And there's a book published with the findings of all of these researchers, which has many things that we can do right now, surprising technologies that are already in existence, along with technologies that they feel are right around the corner. One of those technologies being the bionic leaf technologies. Others include technologies for drawing drinkable, usable, pure water directly from the air using electronic technologies, and social reorganizations that could easily be adapted to improve our carbon footprint globally. And I'd like to start a reading and discussion group on this to discuss this book and others, possibly online, possibly a hybrid system where we do video conferencing along with a shared meeting space and things of that sort. And if people are interested in that, please contact me at the email address I'll give at the end of the presentation, and we'll start talking about setting something like that up. And of course, that feeds directly into our whole idea of dealing with bionic leaf technologies and fixing the Earth's human habitable biosphere using these kinds of tools. The Bionic Leaf Development Kit project had its original concept as developing a solar power cell device that is a hybrid between engineered methanogens and other microbes to electrolytically remove CO2 from the air, take that CO2 and hydrogen separated from oxygen by electrolysis, feed that to the methanogens and other microbes in the mix, and they would convert the ambient CO2 and the hydrogen into methane, which we would capture. And that captured methane could either be used as fuel, and if it's burned again, it burns cleanly into CO2 and water vapor again, thus closing the loop and therefore not contributing to CO2 emissions. And if the system's super efficient, which we expect it would be, it'll actually start removing the excess CO2 in the atmosphere, meaning we'd have huge amounts of effectively neutral, insofar as the environment is concerned, fuel. And methane can also be used to feed engineered yeast and bacteria that can be programmed to make plastics, drugs, advanced foods such as protein feed, and other things. And just as an example, the company Callista, which has been in business for over 20 years, has been manufacturing from natural gas, which is mostly methane, a high-quality protein feed that can be used for salmon farming. And it's been used successfully for that for over 10 years. And they've actually started a branch in the United States. They're actually making food now for cattle and testing out human feed as well at this point. And so this brings up the possibility of manufacturing food that is usable, good, high quality for humans and other creatures, and that could change agriculture. And with that in mind, part of our project also is we will harvest the biomass of the microbes in our device, pelletize them, and then use them for fish food to demonstrate that this is also a way not only of generating food and methane for production in other areas, but also a way of generating food directly from the device itself. The endpoint, of course, is to develop devices that remove excess CO2 via bionic leaves powered by space-based solar power satellites. Space-based solar power satellites would be manufactured using resources from the moon and nearby asteroids, and therefore wouldn't affect the Earth's environment, and can collect virtually unlimited amounts of solar energy and beam it back to Earth for use in these sorts of devices. And this comes out of work done by Gerard O'Neill way back in the 70s, and actually has been mentioned a great deal by Jeff Bezos, the founder of Amazon, and who's behind the Amazon Catalyst program that we're getting our funding from, as a way of dealing with our increasing demands for energy, while at the same time not damaging the Earth's environment. Solar panels and wind power and other alternative energy sources, alternatives to fossil fuels, are environmentally damaging themselves because they require rare earth metals in order to be manufactured. And that is a very environmentally destructive mining process to get those rare earths and use them. Rare earth metals, on the other hand, are highly abundant in near Earth asteroids and also on the surface material of the moon. And it's possible with technology that's been in existence for actually a couple of decades to build solar power stations and beam energy safely directly to Earth for use in conventional commercial power or to power devices such as the bionic leaves. And I can direct you towards several interviews that Jeff Bezos has given where he proposes that Earth be rezoned residential and light industry and to move all heavy manufacture and energy production into Earth orbit and the moon. Not a far-fetched idea, technologically feasible. And remember, his first project, of course, in space is Blue Origin, and lowering the cost of Earth to low Earth orbit transport is one of the necessities for this kind of thing. and that's where he's making substantial progress and investing in. So, of course, are Elon Musk and Paul Allen. Building. Well, we've started building our prototypes of our device. We've developed an efficient ambient air CO2 harvesting device, which generates a powder that contains fixed carbon dioxide directly from the air. That powder can be used to generate CO2 again, safely and in a recyclable manner. That CO2 can be fed into a bioreactor container, as would hydrogen that's captured from electrolysis. That's pictured here in the phase 1 proof of concept device in the middle. And we're in the process of finishing up the testing of what amounts to plumbing issues, being able to do gas sampling with a gas analyzer we use, and making sure all the collection processes are efficient and so forth. And we're about to start working with mixes of microbes to see if we can get them to convert the CO2 that we've captured and the hydrogen that we've generated into methane that can be used for fuel and stored for other processes. We also are starting the finishing work on what we call the phase 1.5 pre-production device, which is the final version of what we think our bionic leaf system will look like, and with the eye on mass production, possibly through putting the instructions up on the internet for people to download and print out using 3D printers so that they can do it yourself and tinker with the device and play with it and hopefully make improvements. And so that's where we are right now. And if you show up on Thursday evenings or Saturday afternoons and evenings, we have work that we're doing on all of these devices and all of these projects. And we can use assistance and help from people from a variety of areas. Everything from, if you know anything about electronics or chemistry and microbiology, or just are really handy with tools for working with plastics and things of that sort. People who are interested in doing some computer simulations, or even artists who are doing animations. Those are all people that we're interested in talking with and having join us. You don't have to be a quote unquote lab rat who wants to do bench work in the scientific sense to be a big contributor to this project. We need all kinds of minds and talents for this. Now, this project overall came into being from discussions on an informal group that I maintain on Facebook called the Biospherics Working Group. And the purpose of the Biospherics Working Group is to develop technologies for both fixing and maintaining the human habitable biosphere on Earth. And also, the technologies that we're developing could also be used to terraform other planets like Mars. Keep in mind, though, the general idea here is that we've already modified Earth over the last century substantially, and not in a way that's good for us. And so it's likely that the very first planet that we'll terraform will be Earth itself. Now, this organization has the Bionic Leaf as a project. Hopefully, there will be many other types of projects, but the Bionic Leaf is the first one. It's funded by an Amazon Catalyst grant. And we've been lucky enough to find SoundBio, and they've generously agreed to act as our host lab where we can build and develop this device. And hopefully there'll be many other such projects at SoundBio Lab. And we're open to talking about other types of lab operations as well, if we need different types of technologies or space than, say, SoundBio itself can provide. There are many other biospherics projects and opportunities. One I've already kind of mentioned, which is an atmospheric water generator, which pulls water directly out of the atmosphere using energy, and can be located in the desert or any other location as long as the humidity doesn't drop below 18%. And so these devices are already in existence and are actually being used by the US military in the Middle East to generate water, drinkable, potable water for bases. Methanotrope engineering. I mentioned that you can engineer bacteria and, of course, also yeast to feed off of methane and other feedstocks that might be generated by a bionic leaf technology to make plastics, foods, and other things. Food production from methane, and that's an interesting area. And it would be interesting if we could get a collaboration going with Callista on this as a demonstration project. Remember, the objective of this is primarily educational, not necessarily to make a production device that could go out and be commercially available to people to set up in their houses and so forth. That might be an endpoint from one of the people or groups that might download our device and tweak it and work on it to make it more viable and efficient. But our objective is to change the way people think and like get people to recognize that there are technological solutions to these problems. Simulation of bionic devices and deployment is one other thing. Other products from methane is another. Real-time displays of Earth status, like the Jet Propulsion Laboratory's Earth Now app, which you can download, or at least you used to be able to download from the JPL site, which displays a real-time visualization of Earth along with data such as changes in temperature, changes in CO2 levels, the concentration of plankton in the Earth's oceans each day is actually mapped by satellite and is projected onto this particular display. Harvesting CO2, which is still an interesting and viable area of research to efficiently remove CO2 from ambient air and then repurpose it for things like the bionic leaf. Solar power systems of all sorts, gas sensors for detecting the gases we'll be working with, 3D printing of bionic kits, exploration of social, political, and economic consequences, which is very important because this could have really profound changes in store for people. For instance, imagine if you could produce food efficiently using such devices and you don't require arable land or fresh water. The possibilities for upsetting the current agricultural system are huge. And that's, of course, of great political, economic, and social consequence. And we need to explore these things while we're creating these kinds of technologies, just as we needed to explore the consequences of genetic engineering. Homebrew meetings. We want to set up a social network system combination of on-site meetings and a virtual presence through video conferencing and social networking tools to mimic what happened early in the IT industry, where you had homebrew meetings where amateurs and professionals would get together, share their ideas, share devices that they had put together. That was a time when people were buying computer kits and building their own computers at home, learning how to program them. That's where the Apple originally came from, the Apple computer, and also VisiCalc, the first useful program that people allowed people to do balancing spreadsheets and financial reports and so forth. It was the first viable, easy to use spreadsheet software. So we're looking to do that. I'm also interested in business models because we have to obey the laws of finance and as well as science in developing such devices. Space manufacture and colonization, which, as I mentioned, were part of Jeff Bezos's view on how all this would fit together. And many, many others that I'm not mentioning here are not imaginative enough to think about. So homebrew meetings, social media, and collaboration are a key part of what we hope to do. And I'm hoping that a lot of people in our group tonight are stimulated to meet with us again, to join us in the lab work, but also help us build our first local homebrew meeting on a regular basis. We're going to be having these meetups once a month at the end of each month, Fridays at 7:30 p.m., probably here at the Sound Dial location, if that venue continues to work out in terms of the arrangement for the presentations and so forth. And we're hoping that people will help us with this. If you're interested, be sure and contact me at my email address, which I'll give in a moment. And, let's get moving on all of this sort of thing. There's a lot to do, and I think that's a really interesting project. We've gotten support from Amazon in the form of their Catalyst grant program, and we definitely have a lot of help from SoundBio Lab as a place to do all of this, both in terms of meeting up and also actually doing the work of building the device. And we're really grateful to them for stepping up and acting as host for this project. So my email is mark.miney@biosphericswg.org. And if you send me emails at that, I'll respond within the usual 48 business hours as best I can. And I look forward to hearing from all of you. Here's the core Bionic Leaf team kit at this point. We have Bernstein, Mike Galadicki, me, Mark Miney, the speaker tonight, Zach Muller, who's the director of SoundBio, and Herbert Sorrow, who is in the bioengineering department at UW. He's a synthetic biologist. Mike is also a synthetic biologist. Bob is an electrical engineer and inventor who is local to the area and has been involved in a number of really important, well-known technologies in this area, including one of the very first virtual reality visual systems. Paul Schackenberg is a physicist who brings a lot of experience and knowledge and actually loves to work at the bench and get his hands involved with doing the chemistry and the building of devices along with the rest of us. And then Alan Bond, who's a graduate student in the UW microbiology program, who brings a wealth of knowledge and has provided us with a lot of interesting ideas and been a big help. And we'd like to add all of you to this Bionic Leaf team, Kit team, and join us in building this device and possibly contributing to changing things to help preserve the human habitable biosphere here on planet Earth. Thanks. And we have room now for questions and answers and further discussion, and also for finishing up the pizza and soft drinks. Thank you again.